Watch how this wall goes up. Every vertical joint stacks directly above the one below, forming one continuous line from top to bottom. Looks clean, looks solid. But that straight line can become a weak plane. If the wall settles or takes an impact, a crack has a clear path to follow, right along that seam. And instead of being forced to change direction, that crack can continue straight along the height of the wall. Engineers have known this for thousands of years, which is why almost no structural brick wall around you is built this way. This is called a brick bond, the pattern in which bricks are arranged so that vertical joints don't line up from one course to the next. The horizontal mortar joint is called a bed joint, while the vertical joint between bricks is called a perpen joint. To create a proper bond, these vertical joints must be broken from one course to the next. And the way we do that depends on how each brick is laid, as a stretcher showing its long face, or as a header showing its short end. Now, let's see what happens when we arrange every brick as a stretcher. Course after course, each brick is offset by half a brick from the course below. This is called a stretcher bond, also known as a running bond. It's quick, clean, and one of the fastest brick bonds to construct. That's why it's commonly used for half-brick partition walls, wall facings, and the outer leaf of cavity walls. But notice something important. This wall contains no headers. So the bricks don't tie the wall together through its thickness. That makes stretcher bond suitable for thin, non-load-bearing walls, but not for a full-thickness load-bearing wall on its own. So, what happens if we flip the idea completely and lay every brick as a header instead? This is header bond. Here, every brick spans the full thickness of the wall. Unlike stretcher bond, this creates a full thickness arrangement. But on a long straight wall, it requires more bricks and more labor without offering much practical advantage. Its real advantage appears when the wall begins to curve, because the shorter header faces can follow a curve far more smoothly than long stretcher faces. That's why header bond is especially useful for curved and specialized brickwork. So if stretcher bond uses only stretchers and header bond uses only headers, what happens when we combine the two? Not randomly, but course by course. First, an entire course of stretchers. Then, as we look from above, the next course is laid with headers, tying the wall through its full thickness. And that pattern repeats, one complete stretcher course, followed by one complete header course. This is English bond. Once the wall is complete, the pattern becomes clear. Stretcher course, header course, stretcher course, header course. But look closely at the corner. Right next to the corner header is a specially cut brick called a queen closer. It may be small, but it plays an important role. It helps maintain the bond and prevents vertical joints from continuing directly through successive courses. The result is a strong, fully interlocked wall, with header courses regularly tying the wall through its thickness. But English bond has one drawback. Its appearance is less decorative for exposed brickwork. So, for walls meant to be seen, another pattern became popular: Flemish bond. Instead of alternating entire courses, Flemish bond alternates headers and stretchers within the same course. Header, stretcher, header, stretcher. And in the course above, each header is centered over the stretcher below, creating the distinctive alternating pattern. As the pattern repeats, it creates the distinctive checkerboard appearance that makes Flemish bond especially popular for visible brickwork and facades. At the corner, a queen closer helps maintain the correct offset and keeps the vertical joints from lining up. Compared with English bond, it is generally considered less strong. But where appearance matters, Flemish bond offers a balance of strength and visual appeal. 4 bonds, 4 different ways to arrange the same brick. And each arrangement changes how the wall looks, connects, and performs. But these 4 are only the beginning, because the next bond takes a completely different approach. It doesn't just change the pattern, it changes the way the wall is built. This is rat trap bond. And unlike every bond we've seen so far, the biggest difference isn't just in the pattern you see. It's in the way the wall is built. Instead of laying every brick flat, the bricks are turned on edge. As each course rises, the bricks are arranged to create a continuous cavity within the wall. That means the wall isn't solid throughout. Inside its thickness, Hollow spaces are formed as the bond continues. And that's what makes rat trap bond fundamentally different from the bonds we've seen so far. The result is a distinctive pattern that uses fewer bricks and less mortar than solid brickwork of the same wall thickness. Those trapped air spaces can also help improve thermal insulation, a different arrangement, a hollow wall, and a smarter use of material. That's rat trap bond. Before you go, here's a challenge. The next time you walk past a brick wall, can you identify its bond? Don't look at the bricks, look at the joints. Take a closer look. Then tell me in the comments which bond you think it is. And next, we're moving from the walls to the slab above. Subscribe. And let's keep building.